Great, okay. Dropbox, BIFC, workbook, physics, electricity, potential divider. Okay. Open in. I did click open, didn't I? Oh yeah, we did. Okay. And then I can't remember what I'm doing. Full screen mode? There you go. Okay, potential divider. If you can write that down, please. Got that? Yeah. It's a very simple enough circuit here to finish off the electricity potential divider circuit. Okay. Let's have a look at the circuit below. So, I mean, very, again, simple enough circuit. Let me draw your attention to the four things here. So, this is what we call the supply or the input voltage. So you have some kind of power supply here, and you measure its voltage, and you call that the input voltage. Then you have some voltmeter here, and you measure your voltage, and you call that the output voltage. This is a fixed resistor, and this is a variable resistor. Now, we'll have a look at what happens with this compared to this and the changing of this. So, we'll start off by using the loop rule. So if I use the loop rule, I get V in minus I or 1 minus I or 2 equals 0. Okie dokie? So I can rearrange this, you know, I can take this to the right, take out the, I better write it down, take out the I. So I'll just put the steps here. I have V in minus I or 1 minus I or 2 equals 0. So V in equals I or 1 plus I or 2. So V in equals I or 1 plus or 2. So then, what am I getting to? I equals V in over or 1 plus or 2. Now you can write down all the steps if you like to go from this line to this line. You know. But first, you should draw the circuit. So we'll get that done. Thank you, and I'm so tired and hungry. Thanks. Quick, child, this is the first slide. You didn't miss anything. Okay, I see some of you. Kim, do you have all of this? Yeah. Did you want to write down the steps from here to here, or is this okay? I mean, can you see how to go from here to here? Yeah, you don't need to write down the steps. Okay. Have you finished your maths yet, or are you still doing probability? But did you have your last lesson on it, or? No? What was your last lesson?
Probability with tables.
Oh, that is the last lesson.
Oh,
Yeah. So yes, you finished now. Congratulations.
So does the one on top say 1 or out?
Out.
Yeah.
Be out. Is that okay? Now, let's go back to my notes here. The I have the formula, the triangle VIR. So what does I equal? V over R. Now, to be very careful which V and which R. So I'm talking about, I guess, here, I'll use this one. So the I here, it's obviously the same as the I here, which is the same as the I here, because there's only one loop. So what could I say the I equals? What over what? Yeah, which V but which R? I'm going to use this one. So V out over R2, yeah. So I can say now V out over R2 equals V in over R1 plus R2. So the last thing to do is just to bring the R2 up to the right. And this gives us our formula here. I'll write it down here a bit neater. V out equals bracket V in over, I'll put the R2 inside. R2 over R1 plus R2 times V in. So in other words, you can calculate the output from the input if you know the resistors. This is the potential divider formula for this circuit. Lets you calculate the output from the input. You'll need this. Got that formula? Now have a look at the circuit. Which resistor can you change? Which resistor can you change? R1 or R2? Which one is the changey one? R1. So what would happen if you, according to this formula, if you made R1 equal to 0, what would the V out equal? No, actually you're looking at R2. Yeah, V out, that's R2. That's 0, that's R2. So 1 times V in, V in. Yeah, so as you said, V out would equal V in. Now what would happen if R1 starts to increase? What would happen to this fraction? Does this fraction get bigger or smaller as the R1 increases? Smaller. So what would happen to V out? Would it be bigger or smaller than V in? Smaller, because what you're doing is you're multiplying by a decrease in number. This is getting smaller. You know, like maybe it becomes 1 over 6 or 1 over 7. You know, yeah. So in other words, the idea is this: by increasing R1, you reduce the output voltage. So this circuit is a way to reduce voltage. So, why might you want to reduce voltage? Well, and didn't we say your phone, what was it, 5 volts or something, 6 volts? 5 volts. But what's the power supply voltage? Just what how much?
120?
Oh no, that's America. Here?
210?
220.
220.
220. So you need to figure out a way to take 220 down to 5. That's what this circuit lets you do. It's a way to reduce voltage for low voltage appliances like phones, laptops, things like this. Yeah, is that, get the idea? It's a voltage reducer, so to speak. Okay. So the definition now of this, the potential divider allows for an input voltage to be reduced. The output voltage can be found from this formula, which you have. But I think it's good. I think you wrote this down already. Did you write this down?
Mhm.
Yeah. So it's the same thing I'm saying here. It lets you reduce an input voltage, and you can calculate it by using this formula. Okay, so I think you have that already. Do you want this write this down, Joe?
I just take a picture.
No, go ahead, write down. Because I'm nearly finished. I'm at 4 of 7, so there's
Okay.
lots of time. I know you like to write all my slides down. I don't want to make you unhappy. What have you got after this class?
That's it. Speaking.
Speaking test. Who's your speaking partner? Is this good or bad news?
No idea.
Have you practiced before?
No.
Who's your speaking partner? Is this good or bad for you? Is it? You two speak together a lot? Yeah? And, okay, so they just made whoever you sit beside your partner, is it? Okay, I think there's probably just one example and then that's it. So like I said, it's very short. You got this, Joe?
Yep.
Yep, okay. So I tried to make it a little bit harder because it's just one formula. So a circuit requires 11 volts. However, the mains provides 220. And what you have is a 10 milliohm resistor and an X milliohm resistor. And X is, you know, the one that you can change, obviously. That's why I'm calling it X, because you have to pick the value you want, okay? So just very quickly, let's just draw what we have here. So here is X times 10 to the minus 3 ohms, because I'm measuring in milliohms, I said in the question. And this one here, what is it? 10 milliohms, so that's 10 times 10 to the minus 3 ohms. And then I have my 220 volts here. I'll draw it as a plug. No, what am I doing? Stop messing about, Stephen. 220 volts, and you want to pick the X here. And what value of X do you need? You need to have a voltage here of 11. That's what you want across this resistor, 11 volts. So if I've done part 1, now find the X. So if I use my formula, what's my formula say? V out, yes, equals R2, which is 10 to the minus 2. It's that one, that's R2. What's wrong? Are you okay? Over R1 plus R2 times 220. Okay, I can figure out what the X is from this, but I want to clean this fraction up. So I'll cross multiply first actually. I'll have 11 times 10 to the minus 3x plus 10 to the minus 2 equals 220 times 10 to the minus 2. I'll multiply everything by 1,000. So that'll be 11 x plus 10 equals 2200 if I multiply by 1,000, I hope. So that means x equals 2200 over 11 minus 10. Can someone calculate that, please? 190. Okay, so you need to use 190 milliohms on R1. Is that okay? I'm just using one formula. Now, The last part is a 2 ohm resistor is connected to the output. What's the voltage across it? So here's the thing. The reason you make this circuit is to reduce the voltage. And you reduce the voltage and then you connect something to it. So in Andek's case, maybe he wants to take the 220 down to 6 for his phone. So you make your circuit, you take the 220 down to 6, and then you connect your phone into the circuit. So in the picture here, what's happening is you take out the voltmeter, and once you see, okay, I have the voltage I need, 11 volts, then you connect in your phone.
So
Yeah,
the 180 is really old.
the 180,
The 180.
the 190 was milli, I hope. Which 190? Oh yeah, 190 was milliohms. Yeah. Because I know I did it a weird way just to make it hard. I called X milliohms at the beginning. So if you got X as 1, it means you got 1 milliohm. I just did this to be a jerk, that's all. Okay, so I'll connect the 2 ohms. Do you understand? You change the resistor, you look at your voltmeter, you say, okay, I've got 11 volts, take the voltmeter out, and then connect your phone. But there's a small problem. The voltage doesn't stay at 11, it changes a little bit. Why do you think the voltage changes? Why do you think it's changed? It's not going to be 11, it changes a little. What's the reason? I wonder if anyone can see. Any ideas? Yes? Yes, it's as simple as that, yes. You all seem very shocked by this. So, if I put another resistor in, I'm changing the resistance, which means I'm changing the voltage. Now think about it. Which resistor has changed? Is it like the R1 or is it like the R2? Which one has changed by adding in the phone? The R1 or the R2? R2 has changed, hasn't it? It's like my R2 is different now because I can think of these as one resistor. How do I calculate that? 1 over R2 equals 1 over 2 plus 1 over 10 to the minus 2. So I get 1 over R2 equals something. 2 times 10 to the minus 2, 2 times 10 to the minus 2 plus 2. So then R2 equals 2 times 10 to the minus 2 over 2 plus 2 times 10 to the minus 2, which equals 0.02 over 2.02. Right. Yeah, what's that? It's going to be pretty small. 0.0... 0.0099. Okay. Yeah. Now, if I use the formula, I can calculate the voltage. So let's calculate again. V out equals R2 over R1 plus R2, and we said R1 is 0.190 plus 0.0099 times 220. So my answer now for V out is no longer 11, it's, can you calculate? $10.9. Yeah. And I'm sorry, do you mind putting the light on if it's working? We're back in action. Ask, please ask me. I'm not an angry teacher, I like to help. What's your question? This guy? This thing here?
Yeah, the second one.
This one?
Yeah.
Ah, I just add these two together and I got this fraction. So, if you have a calculator you can do it. I was just doing it in my head. I used this guy Did I make a mistake?
Isn't it just 10 to the power minus 2?
Yes, not Seba, sorry, yes, Kim, thank you. Thank you, Kim. So how come I got the right answer with the wrong number here? It's interesting. 10 to the minus 2 plus 2. I shouldn't have had the 2 here. Okay. So that should have been 1. So how does this change now? 0.00495. 0.00495 and then 0.00495. Can we recalculate it? I have a feeling I might get the same answer. Let's see. I'd be happy. Oh, that hurts. That's not close to 11. Are you going to say I made another mistake?
Yeah.
Thank you. Where?
R2, you pick the fractions, is supposed to remove the 2 and the...
Ah, I'm so stupid. Okay. I should have removed this 2. So that's 2.01. So, third time now. 0.02 divided by 2.01 is
0.00995.
Isn't it?
995. Yeah, so that's just 995 and that's 995. So what is this now? It might even be the same. Yeah.
Isn't it 0.01 over 2.01?
No, that 0.02 is okay because that came from that and that came from the bottom line on the previous one because I flipped it. So, no, it is okay now.
10.95.
Ah, that's even better. Closer to 11. Okay. Oh, thank goodness. Okay, so the point here was that you can set your potential divider to output 11 volts, but then when you connect your phone, it decreases slightly. Slightly. So in real life, what you would need to do is, set your potential divider to 11.05 volts, and then you connect your phone, and it drops to 11 volts, which is what the phone needs anyways. But you don't have to. I mean, I think the phone will still take the 10.95. Perhaps it just won't charge as quickly. Because they make these things have a range, like if your phone is 6 volts, it can probably go from 5.95 to 6.05, I would say. Anyways, it's more dangerous to have the voltage too big than too small. The reason that the number didn't change much is because these are in milliohms. Because if you look at what's happening, this here is quite near the original value of the R2, which is 10 times 10 to the minus 3. It's only a little bit less. The reason it's only a little bit less is because when you use this formula, it doesn't really matter about this. It doesn't affect it much. So anyways, the potential divider works best when you're using milliohms. And this is how it works best. But that's it. That's the only question here. And I think that's probably the last. Yeah. And okay, let's have a look. Yeah, so like I said, it was a short lesson. So what I want to do, I want you to do this one question, just the one question, and then we'll go to mechanics and we'll do We'll do the last mechanics question, which is B3 in a moment, after you try this one. Can I close this? I can close this? Frozen.